Hi everyone, we are researchers from ARI, MIPT and FRC CSC, and we are glad to present our solution for the Object Navigation Challenge 2023. For the agent to operate in human-centric environments, it needs the ability to explore previously unseen areas and to navigate to objects that humans want the agent to interact with. This task can be formulated as object goal navigation. We decomposed the object nav problem into two distinct skills: exploration, where the agent must search the area for the goal object, and goal reacher, where the agent must navigate to the detected goal object and stop near it. We then built a modular architecture that incorporates both classical and learning-based implementations of each skill. To train RL skills, we have leveraged the DPPO as it shows promising results in similar visual navigation tasks. In real-world scenes and photorealistic environments, navigation tasks are complicated by the significant variation in indoor environment size, layout, furnishing, color, and other parameters. To generalize these peculiarities, an agent needs a highly capable encoder to extract all necessary information from its sensors. We address this problem by dividing it into two parts: obtaining a visually robust image encoder and developing a dynamic robust RNN encoder. As an image encoder, we employed a pre-trained clip model and froze it during the training phase. To address the dynamic robust RNN encoder problem, we fused all navigational skills and trained them with one neural network with shared visual encoders and RNN layers in an early fusion manner. The exploration skill needs to be aware of the area's spatial structure to avoid exploring already explored areas, while the flee skill focuses on distance measurements, and the point nav skill mainly focuses on finding the shortest possible path to a point. The reward function of each skill motivates these behaviors.
As a classical exploration skill, we use the PONI approach. PONI builds a semantic map of the environment with 16 semantic classes and uses a neural network-based potential function on this map to predict an intermediate goal. The potential function of a point is a combination of estimations of an area explored from this point and the probability of a goal presence near this point. For intermediate goal reaching, an FMM planner is used. For goal reaching, we used a semantic map with only goal object class. After some goal objects are on the map, we create a path to the nearest of them with a star planner. To prevent reaching false goals, we use semantic map accumulation and fading and do not map the goal objects closer than 1 meter.
To obtain information about environment semantics, we use OneFormer, one of the state-of-the-art methods for semantic segmentation. This transformer-based method uses a single model to perform semantic instance and panoptic segmentation tasks. We leverage the OneFormer model pre-trained on the AD20K dataset and further fine-tune it on a dataset collected at random points on the HM3D dataset scenes. In our pipeline, we only need semantic segmentation. Therefore, we fine-tuned the OneFormer model in the semantic segmentation mode. Here you can see an example of semantic segmentation performance of the fine-tuned model for the goal segmentation task.
To effectively leverage the advantages of both the classical and RL approaches, the skill fusion method must be aware of the benefits that each skill can provide at any given time. We already have cost functions for this purpose: the critic value function for RL skills and the frontier cost function for classical skills. We normalize these functions to the same order based on collected experience, and at each step the agent executes the skill with the maximum value. As our experiments show, RL-based approaches have demonstrated remarkable effectiveness in scenarios where obstacles are not mapped due to the camera field of view limitation. However, when navigating over longer distances, RNNs tend to forget information from the initial steps, whereas classical navigation methods store it as a 2D map. Also, while RL approaches excel at goal finding and targeting, they often struggle to halt in close proximity to the target object. Thank you for listening to us.